So how far did you get in your?
I got through logistic binomial, and I tried to work on some examples, but I had some issues, so we can try to work on them together.
Oh, okay. Cool. I didn't. I read the chapter, but I didn't do any work.
No, I didn't. I would have assigned you, like, I would have given you homework.
Okay.
If I know. Okay, so let's just you want to go ahead and just get into it. I actually leave a little bit early. I got a meeting. I got to get ready.
No worries. No worries.
But okay, so basically, well, there's
just real quick though. We're going to continue this next week, right? And you may.
Oh yeah.
You may have some assignments for me for next week then.
Yeah, actually, we'll go over that.
Okay.
We'll try to figure out one that you can work on.
Okay, very good.
Yeah, it's a good question. Okay, so yeah, this is about all kinds of non-linear, non-logistic kind of models. So these are models where we have different types of outcomes, and one of the most, I'll be honest, as a psychologist, I never really dealt with this idea of counts. This is but when I went into medicine and went into biostats, this is a very common thing, right? Because here's a common thing, so how many days somebody's on a ventilator, right? It could be 0, it could be 1, it could be 10, right? And so each of those days is a count. Or yeah, I mean, there's just a bunch of things that, to be honest, I think a lot of social scientists would just try to fit a linear regression on, which would be incorrect, right? I mean, that's probably what we did back in the day. But anyway, so this idea of counts is it's event based, and it's it's a little bit more complicated, I guess, than perhaps what we're used to. So a couple of quotes from the book. So we're going to focus on Poisson and what are called negative binomial models. Those are both count kind of based models. So we can have a count that can be 0, it can be 1, 2, 3, 4, up to an unbounded max potentially. And then we'll talk about logistic binomial models. And then, there's also, I guess what we have left is probit models, multinomial models, and then robust regression. So those are the things that we'll cover next week. So,
okay.
Yeah. So one of the things that's important about, being able to do count models is that, and I even took this directly from the book just so I wouldn't mess this up, but so each unit corresponds to a setting in which the events are observed, right? So I used to teach research methods, right? And so I would have students go out into the world and try to find, counts, in the world, so some place, how many in an hour, how many people would roll a stop sign, or you know what I mean, or not come to a complete, something like that. So the point is it has to be tied to a certain place, and typically some kind of time interval, right? So there's so it's saying, over the course of an hour or a day or whatever, there has to be some kind of bounded amount of time and place to this. Otherwise, it's not really appropriate to do this type of a model. So a Poisson process is a random experiment that consists of observe the occurrence of specific events over continuous support, which once again is space under time, and that process is stable, right? So that's important, right? For whatever reason, you have reason to believe that the process isn't stable. Once again, this probably is not what you want to be doing,
right,
in terms of models. So also one of the other things that's sort of unique about Poisson processes is we don't have, unlike a linear regression, we don't have any kind of variance or standard deviation, right? So what we typically do is just use the lambda, which is the number of occurrences, right? So this is that's the thing that we're trying to predict, and then excuse me, this is the number of occurrences, excuse me. And so basically we don't really have a variance statistic here. We have just we're taking the square root of the expected value of the outcome. That's basically it. Oh, so there is a deep, I guess we could call it deep pause. I guess that's how you would pronounce it.
Okay.
Deep pause, I guess.
I haven't tried to say it out loud yet.
I know.
So we'll go with that.
I feel like it's important that you have a pronunciation for this stuff, because I don't know why, because especially if you're talking to people about it, you want to talk about it. So yeah, so basically if we wanted to do a density plot for this, which is, how many lambda is once again the number of events that occurred. Yeah, so what I did here was I wanted to just show, this is from I stole this from a site, rcoder.com, and so this is kind of cool, right? So we can change the lambda. So basically the x values are the same, 0 to 50, but we have different lambda levels, right? And so number of expectable, yeah, so I don't know, this is kind of cool. I thought this is when lambda is this for this, the black, I don't know if you can kind of see this, but
yeah,
black distribution, yeah, it peaks obviously earlier and it kind of then trickles down to as we move to the right. And for 10, so you see this as we get further and further to the right, we get these lower and lower humps that are less asymmetrical as we move from left to right. So yeah, these are the kinds of distributions that we would expect for a variety of lambda levels and number of events. So one of the things, one of the other things to kind of to talk about is this idea of over and under dispersion. So because we don't have a variance, we have this issue of trying to assess whether the variation that we have is sort of more or less than what we would expect, right? So I will talk about this idea of how do we detect over dispersion. I would say over dispersion means obviously too much variance compared to what is expectable in this type of a model. Yeah, so I'll talk about that a little bit. I'm using the Roches data set here, which is from the chapter, I forget where, but if so basically what we have here is the outcome, which I forget now. Of course, now that I've done this, I've completely forgotten like what the frickin' outcome was. Forgive me. I'm looking that up right now.
How many roaches were alive after the treatment, right?
Oh, right.
Post-treatment roaches, I guess.
Post-treatment roaches, right? Okay. Yeah. Sorry, I've had a bunch of different data sets in my head. So
I got you, man.
Yeah. So by the way, so I've mentioned Poisson models, but negative binomial models are an alternative when we have over dispersion, right? So this means for whatever reason, the variation that we have in the data, it goes beyond what is expectable and allowable in a Poisson distribution. So then we would use this negative binomial distribution, which has this extra parameter to actually capture how the over dispersion is working here, right? So yeah, so basically here's what I'm going to do. This is I think this was all done in the book. Some of the stuff that I have, I actually ended up working on like one example from the back of the book or like from other stuff. But so now what I'm doing here is do you remember what senior?
Yeah, if it's a senior living quarters, whatever it was.
Oh, right. Okay. So yeah, so we're gonna fit a model. Hold on a second. Let me reboot this. I don't know if you've ever had this issue, but I have this issue sometimes when I don't know, like something goes wrong with my session, and well, maybe it'll let me rerun from the top. Sometimes it gives me this error. Okay. Sometimes I have to like reboot my whole dang. Let me just reboot the whole dang session. Sorry. It's just Lord. Where did I even put my here it is. Sorry, it's rebooting, and for whatever reason, it's
standard.
Yeah. All right, let me just rerun this all. Goodness, come on. Okay. I don't want. All right. Okay. All right. Let's see if we can't finally get this to work.
What connections are trying to open?
I don't know. That's what I'm. It just happens sometimes. Like when I was doing a bunch of like stuff earlier, and all of a sudden it just would start saying, "Hey, you know, we can't open this location." I'm like, I'm not trying to open any location. I don't know. So yeah, I have to figure out what's going on here. But whatever. Okay, so yeah, we're doing.
Oh, maybe it's a connection to Stan. Is that what's going on?
Maybe, yeah, maybe that's what it is. Yeah.
I mean, behind the scenes, this thing runs like a C code. It compiles a program and runs it, right?
Yeah. So maybe it's like losing the connection to Stan or something like that. And so yeah, I don't really know how that happened.
I have to admit to only a shaky understanding of how that connection works.
No, tell me about it. Yeah.
Until we get to that part of advanced R, I don't.
Yeah. So okay, so now we're talking about the number of so you remind me again. Sorry, I need your help here. So yeah, why the outcome is the number of roaches left after the treatment, isn't that right?
Right. There's also a pre-treatment number of roaches. I don't know if you.
Right, which is the exposure.
Is that no exposure is how many days?
Let's see.
How many days of treatment, wasn't it?
Well, I don't know. This is what they did in the book. So I just took.
Yeah, so that's how I can tell because it's the offset. So if the offset's the log exposure, that must be the number of days of treatment, right?
That's a good question.
So roach 100 is the
Yes.
previous roach levels, and Y is the predicted, right? Y is just Y. But what it actually represents is the post treatment roaches.
I guess here's okay. So it looks like exposure 2 is in a well, it's an integer. I don't know. I guess this can't be the number of days, right? Or what do you think? I'm trying to look up what the dang thing means, but I can't even find it now.
I'm looking at it right now. Let's see. Treatment control were applied to 158, 104 apartments respectively. Outcome Y measures each apartment number of roaches caught and set in traps. Different traps had a different number of days, which we label as U, the number of trap days. Yeah, so some of them must have been partial days for some reason. Who knows? Then they use the time as subtracted and turn it into days. So U is the exposure 2 is the number of trap days. Log U is the offset for the logarithmic regression, 15.2, right?
So wait a minute. So you're saying that exposure 2 is the number of days
where the traps were there? Yeah,
traps were there out of how?
Oh yeah, not treatment, not right, not for the treatment, but whether how long the traps were there, I guess. Yeah, trap days. Not I got that wrong. So the treatment was just the treatment. It was a one-time application of pesticides or something, right?
Yeah.
So that's the treatment indicator. Senior was senior building restricted to the elderly. Apartment is a senior building, so that's what that means. And roach 100 is just the number of roaches measured before that, I guess, on the same number of trap days. That's
right.
How they get that exposure the same both times?
Actually, I don't.
Oh no, there's control. Sorry, it's not the same apartment. So some apartments were treated, some parts weren't treated, and in both cases they. No, wait, but still, what is this pre-treatment? I don't know what the pre-treatment roach count is supposed to be. Exactly. I mean, I get what it is. It's how many they did some previous measurement of the roaches, right? But was that done for the same number of trap days? I don't know.
Yeah, this was.
Anyway, it doesn't really matter that much.
You think? Oh yeah. So I mean, so basically, we'll talk about it more later. But so this idea of the offset is, it's including the offset in the model,
Yeah.
is a way to have the beta now reflect the association between the predictors and the theta, which is the rates, which is number of roaches, I guess, or yeah. So wait, you're saying that the exposure is the number of trap days, is that right?
Right.
Dang it, you'd think I would have figured this out better, but of course I didn't. Whatever. That's why this is why it's not a proper presentation, right? It's a work through. Yeah, I guess the question is how many possible days are there? Because I'm only seeing like 4 is the top one. So I don't know.
Yeah. Some had traps were trapped for longer than others, I guess.
Okay. Well, anyway, let's
I would have thought it would have been more likely to be how long the treatment lasted, but it wasn't. So
yeah, no,
so it's just a way to control for the fact that it wasn't, earlier you said the counts have to be for the same, some fixed amount of time, and you just the same amount of time. Well, here the counts are different amounts of time, so the exposure accounts for that, right?
mm-hmm. Yeah, I guess. Yeah. Okay. So here we have
I mean, I found it because it's sort of just like an offset, right? Just like another.
Yeah.
I'm sorry. It's sort of just like another like intercept. It's like just putting an offset in the intercept or something.
Yeah. So that way, yeah. So that way, yeah, what you do is you create it so that you're looking at the relationship, but then you're fixing the estimate, the beta to 1. So, okay. So so this is the number of roaches that were at each place, right? And
yeah.
And then we have the treatments, and then we have whether or not it was at a senior living facility, right? So this is where the test, I guess, took place. So
yeah.
So for each increase in the 100 number of so for what we're saying here is for each increase in 100 roaches, we should see the median estimate increased by 1.31, right? So it kind of makes sense, right? How would you interpret that?
Well, I mean, I'm not sure. I mean, this is what I guess I'm trying to remember what they said, but just looking at it now without remembering what they actually said is, wouldn't you think of that as just being controlling for the pre-treatment, and then otherwise you don't really care about you obviously expect it to be more roaches after treatment than if there was a lot more before treatment, but then what you really want to know is how effective the treatment was, and that kind of just is a control, right? Just so we kind of control for the pre-treatment amount of roaches. That way we can see if the treatment itself had any effect, right?
Mm-hmm. Yeah, so Roach 100 is how many like pre-treatment roaches existed in that location, right? So what we're saying, 100. Yeah, so what we're saying is, and I think once again we can use EXP, we can exponentiate stuff.
I guess he doesn't really say anything about the interpretation for here, right? Does he?
So yeah, if you go to page
oh, I'm in the wrong section. That's why I'm in the 0 to
267, right? So the coefficient, the coefficient is the expected difference on Y for each individual in additional MPH. So they're talking about the traffic one.
Yeah, different model.
Yeah, no, so here what we're saying is
there's I see. Yeah. So he was more concerned about the fact that it was an over dispersed thing, and that was a second Poisson model he uses, is that roaches think it is over dispersed.
Yeah.
But so he doesn't, I don't think he says that. I mean, the only important one is the treatment one, right? That's the one that we care about, I guess. And the other things are just controls.
That's true.
Is that right? I mean, is that how you treat it?
Yeah, that's true. These are just covariates, really. So yeah, so obviously getting the treatment, will be in relationship to a lower amount of post-treatment roaches, I guess is what we could say.
E to the minus 0.79 would be the reduction ratio, right? Or
yeah, so it's
factor
minus 0.79, right?
Yeah.
So basically, I think what it means is the predictive difference of having had the treatment, which it leads to a reduction of 45%, I think.
Yeah,
or no,
55%, but yeah, reduction to 45% what it was before.
okay, right.
So it cuts them down by about half, which is pretty nice, right? And
Yeah,
that seems to match. Like if you look at your raw data, I think that matches pretty good, right?
yeah. And then so if we want to tell about whether or not this is there's over dispersion, which means, you know, basically is there too much variance for what we're trying to do, you divide 1 by point, is it yeah, so that's the
Over dispersion.
yeah, I don't really understand it. Oh, also I got this weird thing about K. I don't even know. I didn't even get into that, but whatever. Yeah, apparently there's something problematic here. But yeah, so this type of, you know, ratio is typically seen as evidence of over dispersion. I use something called the Brandt test, which is like, it's like a test that somebody did, you know, quite a, you know, like to create, to kind of figure out how much over dispersion there really is. By the way, yeah, so this is the posterior predictive sort of graph, which I'm stealing this from the book. This is for the negative binomial. Looks, you know, better than what the Poisson one,
Right.
right?
Yeah.
And so now what we're trying to look at is what's the proportion of zero counts, right? In this,
right.
So this is you know, that's, you know, between 0.3 and 0.4. That's, yeah, it's usually a sign of there's excess amounts of zero, of potentially zeros. So I mean, I don't. One of the things that they talk about in the book is this idea of using what are called zero inflated models.
Yeah, I've used zero inflated Poissons before.
I have, yeah, and also, yeah, zero inflated negative binomial models.
I mean, I actually discovered it quite by accident when I was doing some sales numbers, like sales calls numbers, analyzing our customer, our salespeople's data, and I'm like, oh, there's way too many zeros here. I know, I'll just do a mixture model with zero. I just, you know, then later I looked it up and I found that there was a name for it. I'm like, oh, I'm glad to see this is not just something I made up, but it's
right, right.
It's always nice to see this actually is a real thing.
I know, it's like, yeah, you're like, all my education, apparently it worked. Yeah. So now, okay, so just as a comparison, I'm running the same model, but as a Poisson, right? Because what we're going to do is we're going to compare the two.
Right.
Okay, you know, how well do they work? Now I get this warning again, so
Yeah.
I don't know how much I should really even interpret this. I don't know what I didn't really want to get into it, but just as a way of, you know, sort of noting. So remember, this was like negative 0.7, I think, or something.
Yeah, -0.8, -0.8.
Yeah. So I mean, we're getting slightly different things, and also, so this dispersion test, this function from the AER package, this will give us this is another way of looking at over dispersion. So yeah, this, as you can imagine, there's a bunch of people who don't love using, like, you know, a p-value test to figure out whether there's something is occurring or not, you know. So I typically do it, as well as like there's graphical ways, which I don't have the code for that right now, but there's other ways to kind of like show, you know, if there's more dispersion than it's warranted or whatever. But yeah, so this would tell us that there is actually over dispersion. But we kind of are seeing that because the fact that, like, well, that this is, you know, it's, well, I don't know, can we even really interpret that? I'm not really sure, but
what? Alpha?
Well, yeah, no, the
EPLD?
yeah, the ELPD, yeah, because
ELPD?
ELPD, sorry, yeah.
Yeah.
So yeah, I mean, this obviously is, we want that to be a smaller number, so that tells us that it's probably fitting better. Yes.
Which one's fit 2?
Yeah, fit 2 is that is the actually, no, excuse me,
yeah, fit 1's fitting better, fit 2's worse.
Yeah, sorry, yeah, so fit 2 is the Poisson, fit 1 is
significantly worse, right?
Yeah, sorry, my bad. Yes. So and then also, I don't know why I did this, but I wanted to look at, like, oh yeah, so this is now, I just wanted to show
the posteriors, yeah,
the posteriors, and just show,
I
like, I
remember.
already showed one of them up above, but yeah, I'll show this, yeah. yeah, so I mean, like, obviously this is from the book too, right? So this is not wonderful, right? We don't probably aren't going to use this, but
Right.
this is a lot closer. So yeah, actually this I've never done this before, but I would do that, like, because I've done stuff to try to figure out whether I should use negative binomial or Poisson. Okay, so I started digging into these, at least a couple of the items. I'll talk about binomial models in a minute. I just wanted to kind of, since we're talking about this now, I'll do this bit. So yeah, so we're going to use this risky behavior data set, which is data from a randomized trial targeting couples at high risk for HIV infection. The intervention provided counseling session, blah, 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 blah. So basically we have couples that were put either into control group or the experimental group, in which only women participated, or a group in which both members participated. So
Okay.
yeah, so it's pretty wild. I mean, this whole idea of the women only thing, I'm still trying to wrap my head around that. But okay, yeah. So basically the outcome is number of after 4 months after the intervention, the number of unprotected sex. So that once again, we've got bounded time to kind of give us a.
So somehow these are like restricted to just traditional couples. Is that what I'm getting out of that?
I guess I don't
Or,
know.
I don't know what the right word is, but
Yeah. So I guess so. It's a control group.
they start with the things are couples,
Yeah.
right? So they said there's a control group, and then there's a group where just the women of the couple participated, and another group where both members of the couple participated.
Yeah.
Maybe can consist of counseling sessions. Okay, so
Yeah.
in the counseling session, that's part I missed. Okay.
Yeah.
So if some places only the women participated in counseling sessions, control group nobody did, and the other group both members of the couple came. And if it was a same-sex couple, I guess that didn't happen, or maybe I'm not sure they handled that.
Yeah. No,
that's what my question was.
Yeah. So basically, okay. So
Very interesting. Okay.
so these are couples. So apparently, okay, yeah. So these are non-women alone couples, and so then there's. Let me just go through. I mean, okay. So then, yeah. So they're non-couples, but they're women. Wait a minute. So are we saying they're women alone? So there's more than one woman. I think.
No, what I'm saying, I mean, I think if you just think about traditional male-female couples, right? And the setting is there's these couples, okay? And they're gonna, and there's 3 cases. One case, they don't do anything with those couples, other than, I guess, whatever these measurements are, right?
Yeah.
In the other setting, they counsel the women partner.
Right.
And in another setting, the third group, they counsel both of them as a group counseling, I guess, the two of them.
Yeah.
The two of the couple.
It's pretty confusing.
Yeah, it is confusing. But do you know what all these other predictors are?
Well, yeah. So I actually ended up looking it up like online, like for the other people. And so
find the study.
Yeah. So this is whether or not, well, also there's just other people have done some version. I looked up the variable names just as
okay.
Yeah. So this is whether or not they're HIV positive, I believe. And then
okay.
This is the baseline number of acts, which I
unprotected.
Yeah, unprotected. So I called this the offset. I relabeled this as the offset, and this is the outcome, which is after the follow-up, how many unprotected sex. And also I just dummy coded, gender as male.
Which oh, sorry, what was it before?
Oh, it was just a factor variable of, God, I don't know what is going on here, but like my computer is like
gender.
Yeah, I don't know why, but like, yeah, it won't.
Okay.
Happy. Okay. Yeah. So
very good.
Okay, so the first thing they wanted us to do was, and so I created the offset where this is, one of the things you want to avoid is having log 0 situations. So a lot of times people will just add 1 to zeros as a way of this is what they talked about in the book and in other places. So I don't know if that means anything to you, but yeah,
that's one of those things too you find yourself feeling a little like queasy about, right? Like, okay. They do talk about that in the book, but it's like, okay, I guess.
Yeah, I don't. Yeah, I've definitely Yeah, it's some of
But it's
this.
just a different transformation. That's all, right? Just log y
Yeah.
plus 1. Okay, that's fine. Whatever. That's your transformation. I'm okay with that.
Yeah, I mean, it's just a way of avoiding, zero problems. Okay, so for people who are in so this is, I use couples as the treatment, although maybe that's wrong now that I'm thinking about it, right?
Yeah, couples. So remember, there's, I guess, 0, 0 is the control. 1,
Fully
0
control.
is couple counseling, and 0, 1 is women only counseling. Is my understanding of what we read recently.
So I have to include women alone as a variable then, probably, huh?
Yeah,
Okay, well, that's good. I'm glad we figured that out.
and then right, yeah, those are two different kinds of treatment, I guess, the way I look at it, right?
Yeah, I agree with you though. It's confusing as hell. I don't really tend to understand it, but whatever. Okay, so and then once again, so we want
Offset. You didn't put the offset in.
I did not actually. I did not. Good catch.
Risky offset. That's funny.
Yeah. Oh, okay. Hold on.
Something went wrong.
Oh, it's looking like it doesn't like something here. There are 4 chains. Huh. Doesn't like something.
Well, the first error says specify the column types. Blah, blah, blah. Bayesian fracture missing information was low.
So, like, what if I do pairs and then I like run
Maybe
risk?
it doesn't like to use the log offset. Maybe.
Huh.
Wait, why would you use the log anyway?
Oh, actually, no. You know what? I didn't do it as the log. That's why. Jeez.
Okay, that's what I was gonna say. I knew it seems like there should be a log somewhere. Yeah, it's supposed to be a log because it gets exponentiated. That's right. Yeah.
Gosh. Okay. Well, thank God we're not getting paid for this. I would be
Fired already.
I'd be fired already. Yeah.
Me
Okay.
too.
That seems to have worked, right?
The only
Okay.
bad thing is these things get recorded, and maybe someday
I know.
somebody might look at this.
Please nobody
What are these bozos doing?
Yeah.
My hope is
Okay.
that other people watch this and go, okay, I don't feel so bad when I get it wrong because these guys get it wrong. That's my hope.
That's my hope too. Yeah. So for having couples, the effects of having couples therapy or whatever is, I'm trying to make sure I interpret this right. So does that mean we would have a 62.5% decrease in sexual sexual acts? I believe that's when we exponentiate it, and we have the offset in place. So basically the coefficient should be the expected difference in y on the logarithmic scale for an additional unit of whatever that is, right? So in this case,
it's just an indicator. So
having had it or not. Yeah. So I think I'm doing that right.
Should it be 1 minus that though?
No, because we're not doing odds, we're doing so if you look on page 267.
Yeah. Well, I mean, it's a multiplicative decrease of
Right.
62%, which I would say is that means it's 62% of what it was. So you might also say that. You might also take. Sometimes you like to say that we're like, if it was 98, right, 0.98, you'd say there's a 2% decrease, right?
Right, you're right.
98% of what it was.
Yeah,
I think
it's actually a 38%.
Yeah, he does. Yeah, you look at 267, like the third bullet point, adding a traffic signal, he gets 0.82, yielding a reduction of 18%. Yeah, so.
Oh, I see why. Because you're right. Because in the example they give on this, it's like the log is like 1.13, and so yeah. So basically, it's like a 13% increase, right? So if it's okay. Sorry, my bad. Okay, and then obviously, same thing with women alone. So this is interesting, right?
Slightly more effective. I guess
Right,
that within,
has a stronger impact.
significantly more effective. That's
Yeah,
interesting.
yeah. And then so then
Well, I'm of course attributing causal things right away, which you're not supposed to
that was
do. But
hard, right?
yeah.
Okay, so this is the second part. So the second part was they wanted us to go beyond just treatments, and so I included gender, and I included whether or not they had HIV, and this is we're still doing a Poisson model too. So just
Okay.
let's see here. All right, so now when we include gender and we include, HIV status, obviously the couples effectiveness of the couples things drops, pretty substantially by half, almost. And the women alone is, it doesn't really get affected that much, but
Okay.
yeah, but being HIV positive apparently is a good predictor of lowered unexpected sexual acts, which that sounds plausible, right?
Yeah.
Okay, and then the last one here is, okay, so this is now, all right, so and then this is me going back to the original sort of uh couples treatment thing. I didn't include that was before I figured out to include this, so let me put that back in. And then let's so this is now the same initial model. The only thing that's different is I'm using negative binomial as the linking function here.
You got to put that log offset in though.
Dang it. This is why I need you with me like at all times. Well, you know what? I don't even think I didn't do it for the first one either. So shit. Okay. So yeah. Let's see here. Make sure I run this again. And okay. Okay. Well, that obviously had an impact, right? So the couples thing isn't nearly as impacted. The HIV thing is not nearly as impactful.
Right.
So that's, okay. So I'm glad we added that. Good catch. Yeah. So this is now us just doing it as a negative binomial. And I don't know. Yeah, I didn't actually set the I didn't actually do anything to compare the two models, but yeah. Okay, so now so we have negative.
Oh, interesting. That erases the difference between the.
Yeah, sort of interesting.
And look at the reciprocal dispersion. Is that, what does that mean? I forgot already.
So
0.37 means that it's a lot, right?
Yeah, it's a lot. Yeah, so basically, I think the degree to which this is above 1,
3 times the thing. Yeah.
So
almost 4 times the.
Exactly. Yeah.
So that had a big impact on the fit.
Yeah. Yeah. So anyway, but yeah, actually, one of the things I could do is, well, I could do that in my little. It's probably clear that there's dispersion over dispersion, so let's leave it at that. But yes, we're almost out of time, and I haven't even gotten into well, okay, yeah. So this is part D. So these data include responses for both men and women for participating. Does this give you any concern with regard to our modeling? Yes, I think that's what we were trying to say here, right? So for women alone, okay, actually, so let me ask. So if we have a woman and we have 0 couple and we have 0 women alone, what does that mean? That means that
they didn't have any counseling, but they still did the survey, right? They're the control group.
Oh, okay. So that's what we said. Okay, I wasn't sure. Okay, so there's no counseling whatsoever, and they're also HIV negative. Okay, but then so if it's men who are 0s and zeros, that just means they're men who are in the control group. I guess the concern you have is there's no men alone condition, you know, it's like there's no that's the effect of that is sort of
Right. So when you interview the men, they weren't counseled. So it's kind of, yeah.
well, half of them
The men and the women alone, there should be men, right, in the women alone group because they're part of the couple. They just weren't part of the counseling.
Oh, let's see.
I guess, right?
See. It's a good question. Oh yeah, there are.
Yeah.
So wait, because that means the woman is in a counseling session, or excuse me, the man is in the counseling session.
No, the woman is, but the man is not being it's still being asked, you know, to in the post treatment survey, like about these unprotected sex acts, right?
Man.
Okay. I don't know what that I mean, there is some concern there, right?
Yeah, there is. I mean, because it's just not, it's a confounding variable, right? Because well, I mean, first of all, yeah, I don't know. I mean, is there equal numbers of ones and zeros for each 0 and 1 of the I don't know. That's a good question. Yeah. Anyway, we're almost out of time.
Yeah.
Let me just go through a couple other things. I probably won't,
okay.
I won't get through all of, well, it's actually, there's not that much left, but so okay, yeah. So the 15.2 was the offset in Poisson of a negative binomial regression. So when I put in the logarithm of the exposure into a Poisson model is an offset as an offset is equivalent to including it as a regression predictor, but with the coefficient effects to 0. So, or excuse me, it's a value of 1. So I found this in the book or someplace else. When we use the offset, the regression coefficient now reflects the association between the predictors and theta, which is that rate variable that we're a rate of acts, a rate of traffic accidents or whatever. So yeah, other than that, I didn't really have anything else. I didn't come up with anything else, but if you had anything else, I gotta think about that more. To be honest with you, I've done Poisson models and negative binomial models, and I haven't used an offset because, well, we didn't have it, right? I mean, so I've done
the offset would have been the same number or something. It wouldn't have mattered, right?
Right, exactly.
If you that traffic, the one example you had sent your students out to measure how many people ran red lights or whatever.
Yeah.
If they all measure for 2 hours or whatever, then that would have been fine, right?
Right.
The control the exposure would have been the same. So
yeah. All right. Well, just get in real quick to binomial regression. I mean, we've already done this in so many different ways, but I got kind of stuck here, and so maybe we can address this and then try to finish it up next week. But
okay.
So
that's 15.3.
Yeah, 15.3. So on page 7 or 270, basically what they wanted to do was have what was the if you hold on, look at it here, it's yeah, we want to see simulate 100 players, each shooting 20 times, and look at what
right.
Where the probability is so is a linear function of height. Okay, so yeah, in the original one we were just taking the 20 each time, right?
Yeah.
Now what they and this is what it was originally. So now what I'm doing is I'm saying, hey, use a uniform distribution, min 10, 30, and give me 100. One thing that I did do wrong at first was if you don't round, it will have it be like 2 or 3 decimal places, and then you can't get this to run the R binom function, right? So yeah, let me show you real quick.
Yeah, you need both.
Okay. And I haven't even looked at this yet, so I didn't have a chance. So like, I'm assuming this means for every inch in height.
Right, and that should match what you put in the model, right? I mean,
Right, yeah, so height is in inches, I'm assuming those are inches. Yeah, there's got to be inches, right? Yeah, and so this is the number of shots that they took. This is the number of makes, and then yeah, this is how tall they are, right? So yeah, I mean, obviously the difference here between this and logistic regression is logistic regression, we just have a simple dichotomous outcome of, did the person die or not? Did they graduate or not? Blah, blah, blah. This is now, how many, there's out of so many like prescribed number of events, how many were successful, whatever that means. So, oh yeah, and then I was going to start getting into this, but I ran out of time. So how about this? I got to dash in about 5 minutes at the most. So let's maybe talk about like, so for next week, maybe I can give you one and I'll try to work on some other ones.
okay.
Yeah. How about one of my graduate school professors' data is in here. If you go to 1513,
1513.
yeah, that's a multinomial choice model on predicting the Academy Awards. Actually, I know this paper. I read this paper. Yeah, basically the gist of it is that I don't know, maybe it's not this paper, but yeah, like women winning best actress is not predictive of like the overall success of the movie, but it is for men. So like if like women are like touted as like the best thing in that movie, it's less likely to be like considered a best picture nomination or something like that. I forget, maybe this is, yeah, but yeah, why don't you work on that one? And
so that's for that like weird that's that weird choice section in here, which I think quite really fully grok. So I guess that's a good idea.
Well, if you want to do this, I mean, if you want to just, okay, actually, you could do, if you don't, I mean, I could work on that one instead. You could do, let me see. Well, I haven't talked about Logit versus Probit, but you could do,
okay,
do 15.5. I don't know.
15.5.
Yeah.
Yeah, I could do that one.
Yeah. I mean, you can pick whatever you want. And then like, yeah, maybe 15.6.
Okay.
They're kind of related. Maybe that'll be like, yeah, that will be.
Oh yeah, that's a good idea.
Yeah,
because that it's kind of interesting because one of the notes that has like, why would you ever use the Probit? I didn't get it. So here you say you could get different estimates. So that'll help me understand that. So that's good.
yeah. And I'll try to do some stuff with the robust regression, and then like I'll do the multinomial stuff. And yeah, actually it's kind of funny, like some of this stuff, like for that the 1513, like they're using what are called discrete choice models, which is what I do in my own work. Like I use DCE models like all the time, which is where you have
well, good. Then you can help me understand what the hell that means. That's actually kind of weird.
All right. So I will yeah, so we will finish this up. Sorry, I'm trying to stop my share. Yeah, we will finish this up next week. But yeah, no, this was a good one. I mean, it's got its challenges, but I think we're moving along. So
yep.
I will
Very
see
good.
you next week, and we will finish up. So I got you for 15.5 and 15.6.
Yeah, and